All right, friends, so again, lesson 16, page 353, adding areas. I want to draw your attention up to where it says example in bold capitalized letters. We're going to talk about Miguel's shape. Miguel draws this shape in his notebook. What is the area of Miguel's shape? Now, friends, we need to do that step by step, piece by piece. All right? So I want you to take a look at how you could have shown your work by breaking apart that shape into 3 rectangles. Here, we have that 5 by 10. Here, we have a 4 by 5. And here, we have another 5 by 10. Where did that come from? I'm going to show you where it came from. These shapes represent the break apart. That break apart looks like this. Here's a shape. Here's a shape. So friends, this would be shape 1. This would be shape 2. And then 3. We have these 3 separate sections that we're working with. And again, why is this necessary, friends? It is necessary because our standard area equals length times the width does not work with a non-rectangular shape. We cannot simply say 15 times 10 and call that 150 square meters. Why? Because this space here has no area. It is blank. It is empty. So we need to break this non-rectangular shape up into 3 smaller shapes and calculate it piece by piece. So piece number 1, we have 50 square meters. Piece number 2, we have 20 square meters. Piece number 3, 50 square meters. And then, friends, it becomes an addition problem. It becomes an addition problem. And of course, we are going to end up with 120 square meters. 120 square meters. Now, friends, let us go back for a moment to our formula, area equals length times the width. Now we can see if we take length times the width here, it gives us 150. It gives us 150 square meters, and you can see that that's clearly not correct. Because again, we are not applying area to this empty space. There's nothing there, it's blank. Okay? All right, let us take a look at number 1 down here at the bottom, where it says the green applied. It's asking you, what is the area of the shape below? What is the area of the shape below? Now, there are 2 different ways, actually 3. There are 3 different ways that we could do this. Number 1, we could simply count the square units that are shown, right? We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We could do that. We could also apply our formula, area equals length times the width. Why can we do that? Because this is a rectangular shape, friends. This is a rectangular shape. So we will take this particular measurement, and that's going to be 5 total feet, because 3 plus 2 is 5. So we have this rectangular shape that is 5 feet long. and 3 feet wide. And of course, it's going to be 15 feet squared. And these, of course, match. Another way we could do it is we could break this shape up if we wanted to. We could break it up right here, for example, and we could do it in 2 separate pieces. There's a piece, and there's a piece. So I could do number 1 as 3 times 3. I could do number 2 as 2 times 3. Here's 3 times 3. Here's 2 times 3. And this would be 9 plus 6, and that's going to be 15 feet squared. So again, friends, I have just in this question offered you 3 different ways to solve it. You can count the square units. You may apply the standard formula because this is a rectangular shape. Or you can break this apart into 2 smaller rectangular shapes and add the areas that you calculate together. Again, always expressed in square units, or the unit of measurement that is identified. Here it is feet. Okay? I'm going to give you a moment to make sure you have all of those notes written down, and then we'll proceed to page 354. All right, friends, please turn to page 354. Page 354, question 2 up at the top, where it's going to talk about Seth. Please follow along here. So it says that Seth uses 1-inch square tiles to build the shape shown below. So this is kind of looking like maybe like a big fat T, right? So, and when we look at this shape, we can already determine that we cannot use the standard formula area equals length times the width and apply it to this entire non-rectangular shape, because we have space here with no area. So we know that we will have to break this up and make a combined or a composite shape. So it's asking, what is the total area of Seth's shape? Again, there are 2 different ways we could do this. First one, I could count the tiles. I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So I could say that this is 14. I know it's inches squared. Again, always expressed in square inches. Another way I could do this is I could make this shape a combined shape, and I could split it. So maybe I want to split it right here. And this is going to be section 1, and this is going to be section 2. Okay? So in section 1, if I say area equals length times the width, this first section, I'm showing a length of 4. I'm showing a width of 2. And that, of course, is 8. In this second section, I am showing a length of 2 and a width of 3. And of course, that equals 6. I need to add those two areas together to get a total of 14 inches squared. Notice how they match. Friends, we can always check and double check our work in math. If these do not match, you need to stop and try it again. If they do not match, you've done something wrong. You need to go back in and correct your work. All right? I'm going to give you a moment too to write all of that down. All right, friends. Now, I want you all to do me this favor right now. I want you all to do me this favor. I want you to take a nice deep breath. Everyone, nice deep breath in and let it out. Again, nice deep breath in and let it out. All right, let us take a closer look at number 3. We're going to talk about kale. Okay, number 3, friends, here we go. Kale draws a model of a birdhouse. This is the model, friends. You can clearly see that this is not a rectangular shape. We are going to have to break this up. We're going to have to do it in a number of different ways because it is asking us what is the total area of the birdhouse. I need the total area. We can clearly see that area equals length times the width cannot be applied to this shape just as it is. We have to break it up, friends. We have to break this up. All right? So when I look at this, this is what I see. This is what I see. I see a shape here. I see a shape here. I see a shape here. And I see a shape here and here. You will notice, friends, that this is now not one section or 2 sections or 3 sections or 4 sections. You can see now that this is 5 sections that have to be computed. 5 sections. You have to take this step by step. Okay? And again, remember, 1 section or 100. The way we do it doesn't change. It's just step by step. All right? So let's number them. This is number 1. This is number 2. This is number 3. This is number 4. And this is number 5. And I need to do this step by step. All right? Always keeping in mind that for each section, I'm going to be applying the formula. So I put this here to help my brain. Area equals length times the width. This is what I'm doing for every single section. All right? So let's take section 1 first. Section 1, I can clearly see, has a length of 2. Where am I getting to? It tells me. See the arrow? It's telling me. I have a length of 2. I have a width of 3. So I have a length of 2 and a width of 3. That's number 1. So I can see that that's 6 square inches. I'm not going to be putting all the writing in right now. Right now, I'm just doing the simple math. So I'm all done with number 1. Let's take a look at number 2 now. Number 2, I can see has a length of 1. How do I know that? Because it tells me. I have a length of 1, and I have a width of 5. How do I know? Because here's 3 inches, and here's 2 more. This whole width right here is 5, because it's 3 plus 2. And so section number 2, oops, that's 5. All done with 2. Let's go down to number 3 now. Number 3 has a length of 3. How do I know that? Because it tells me. Length of 3. And what is my width? It is 6. How do I know? Because 3 plus 2 plus 1 equals 6. So 3 and 6, that's 18. All done with number 3. Beautiful. Let's go to number 4. Number 4, we're back to a length of 1. How do I know? It tells me. 1 times, let's see, what is the width? Again, that's 5. How do I know? Because it tells me I'm adding 3 plus 2. That's 5. So that equals 5. And then let's take a look at number 5. I have a length of 2. How do I know? Because it tells me. Length of 2. What is my width? 3. Because it tells me right here. All right. Now you can see I have section 1, section 2, section 3, section 4, section 5. Could this keep going and going and going and going because I have a humongous shape? Of course. Of course it could. All right, so what do I have left to do? I need to find the total area. Back to my original question. Well, so here we go. I need to add, and add, and add. That's what I need to do. I need to add up all my areas. And I can see that I have 18 plus 10 is 28 plus 12 is 40. Of course, I'm not done because I have to express this in square units and I know what the unit of measurement is. So it is 40 inches squared. That is the total area of this shape. But Sue chose C as the correct answer. Sue chose C. And of course, we know Sue is incorrect. And Sue is incorrect because we never express area this way. It is always expressed in square units. Again, could this be on a test? Absolutely. Could I give you both options and say 40 and 40 square inches? Yes, just to see if you're paying attention. Absolutely. Area is always expressed in square units. All right? I'm going to give you just a moment to make sure you have all of this written down. And then we're going to come back together and we'll have a brief discussion before you get to work. All right?